Okay, so today I'm going to tell a story from the industry with one of our design partners, how Incode is using spec-driven development to scale integration development. And before, let me just quickly introduce myself. I'm Predrag, CTO at codeplain, and here I would like to thank the organizers to organize such amazing conference in Belgrade. Belgrade is very close to my heart. I lived here for 20 years, so I'm really happy that such event is happening here. And before going into codeplain, let me introduce Incode, one of our design partners with which we started working last summer in validating our technology. Incode is an identity verification platform, very successful, probably the leader in the industry, with offices all on 3 continents, and we were very happy to partner up with them. And the reason why we went into partnership with Incode was because they had like a very specific problem. They are developing and maintaining integrations at scale. So first problem was that whenever there is a market need to be covered, they need to provide new integrations in a matter of days. On the top of that, okay, I have the sound. On the top of that, they need. They had 2 big acquisitions recently and acquired some of their main competitors, and now they are moving a lot of integrations into their platform. And on the top of that, there is a maintenance cost for all the integrations. So, and each integration development is a very boring process. I think everyone here in the audience will agree that this is something that you would like to avoid and automate as much as possible. So, of course, they tried it first with using off-the-shelf solutions with Claude Code. Incode is one of very progressive company in terms of AI, did it by the book. Put everything in the context that was needed and define the whole testing strategy and hope that agents will deliver one shot the solution. But fortunately for us, that wasn't the case. And though there were always some small details that were missing in the final implementation, every time it was something different, engineers still had to review all of the solutions to make sure that nothing was missed, especially that the integration that was developed completely conforms to the requirements that were put. And then we went with them, defined the clear goals that product team will define only specifics related to any new integration that is developed. And after that, the system will pick up the rest of the templates that are already in their integration framework and fully automatically do the whole implementation, testing, and maintenance. And how you do that? With spec-driven development. So we at codeplain are taking our approach at the spec-driven development, which basically brings two innovations. The first one is that we are treating specifications as the only source of truth of the code that you are building, where you put all the details in and the requests that you need. And once you have the initial implementation of the specs, you're putting them through a fully automated code renderer that delivers the software in the end without any human intervention. And because my talk is short today, I don't have time to cover both sides, so I will focus on how you write specifications. I'm happy to discuss the code renderer over coffee with you. But what are the parts, how you write specifications? So specifications are written in plain English as this is the most convenient way, but we are putting some structure into it. So I will walk you through some of the good things that actually make us, for example, in the Incode use case, actually deliver the good results. So first of all is that in our specification language called plain, we support reusability of the components. So basically you can build independent modules and then require and reuse them across different implementations. And this actually, first of all, speeds up significantly the whole process, and also is a good practice in terms of software engineering. On the top of that, you can, definitions are helping you to define key concepts that are going to be used throughout the whole specification after that, and giving the exact meaning to some words that are actually can be interpreted in different ways. So basically, with the definitions, you are giving the agent exact knowledge about the thing that you are meaning to express. And then the last part is that code renderer that I mentioned earlier is fully automated, but it actually in the back generates different kind of tests, and tests every functionality separately. So if you would, as a part of the specification that you are providing, every functionality is defined independently, and then you're building the solution one on the top of another. And every functionality is tested as in isolation and as a whole. And so those tests, especially something that we call conformance tests, which are basically end-to-end black box tests, are used after that as regression tests. As you maintain and change the specification, you can always use the existing test as a regression tests. And with all of that, we managed to automate the whole process, but then we went a little bit further, and at the moment with Incode we are introducing like PRD-driven workflow, where the product team defines the requirements in a free form, then the agent picks up and writes the first implementation of the specs. And this is where the most time is after that spent in reviewing the specification, both by engineers and the product team, making sure that the requirements are right, and the rest of the work is fully automated after that. And where we are at the moment with Incode is that we successfully generated around 20 integrations. Their team is now picking up slowly the whole process, and we really are in a position to generate one integration in a day. With time, they gain trust of course, in the beginning, they were reviewing the whole code, making sure that everything. Now, they basically go skim through the pull request, test it a little bit, and ship. But for us, the integrations is just the beachhead. I think we believe that this is some way of spec-driven development is the future of software engineering, that where we will define the high-level requirements. And therefore, we released a beta version that is available. It's really beta, so but we are giving 50 rendering credits to each of you. So please go to codeplain AI, install our tool, and play with it. We would like to hear your feedback.
Thank you very much.
Thanks.
Please, the question. You can do loud. You don't need a microphone.
It is, that is what, Yes. So first of all, we believe that with the spec-driven development, there is a, I think, misunderstanding at the moment that we are going back to waterfall way of developing software, that you will provide the whole spec and then build the software. Actually, what we are doing with our code renderer at the moment is that we want to support fully well, basically quick iterations. So you can only change the part of the specification and then re-render the only code related to the changed part of the specification, while the rest is still there, not changed. And so we believe that actually all the agile approaches will continue to live with the spec-driven development. It is very hard to define, and I completely agree with you, that it is very hard to define static analysis of the specification and confirm that it is correct. What we have at the moment is ambiguity detection, conflicting requirements, and complexity check. So, but all of those three are only identified during the code rendering, not upfront. So that is one of the things that where we are going forward. Yeah, definitely one. I think if you ask me, that is the hardest thing that we still need to solve.
Okay, thank you very much. Because we are in Serbia, I have to give you another question opportunity. Please go ahead.
Yes.
You may have very exhaustive specification, give a big piece of the agent, or opposite, we may have like granularity even by every single task.
Exactly. So first of all, we see codeplain technology still to be mostly applied to engineers. So the engineers will be in charge in handling this complexity of the tasks, and the way how you split them is basically that every functionality is separated, and this is you as engineer are responsible for splitting properly the parts of the software that you are building. So basically, if you would like to build, like, let me give you like the simplest example. You would like to build an integration, and then you have ability to first generate the calls to the API, making sure that, so basically one functionality is make sure that you can authenticate with the AI. And then the second one is make sure that you can connect to the API and send the request, etc. So the whole point is that you are in charge in splitting those requirements. Some of the requirements that you think that are really important, you can go into details, and some that you think that the LLM can pick up whatever is the appropriate solution, you can leave less defined. And on top of that, there are, as a part of the language, we are supporting something that is called acceptance tests, where you can define the inputs and outputs of this particular functionality and what do you expect how to behave.
Thank you very much. And,
Thank you.